Right, it's Maths Q. For some reason, when I start to record, it always moves my place on the page. I don't really know why. Anyway, question one's what I'm looking for. And this question has got a velocity time graph. This is a cyclist traveling on a straight horizontal road between traffic lights. Velocity v, measured in meters per second, time t in seconds. All good. The distance travelled s is measured from when t is equal to 0. So find the values of s when t is equal to 4 and when t is equal to 18. So part A, this is a velocity time graph. So the area between the graph and the x-axis is going to give me the displacement. So t equals 4. This is the area under this sort of triangle. So half times base times height ought to do it. 20 meters. When t equals 18, slightly different setup. When t is 18, we've also got this area at the end, and we've got the area of the rectangle in between. So s will be equal to that initial 20 meters plus 12 times 10 for the rectangle in between, plus the triangle in the end, which is a half of base times height. Half times 2 times 10. So 20 plus 120 is 140, plus 10 is 150 meters. So those are my answers for A. Sketch a graph of S against T for the time period 0 to 18. So in the velocity time graph that I've got between 4 seconds and 16 seconds, I've got a constant velocity. So if I just mark on here 4, 16, and 18, those are important times, and this is 0. Between 4 and 16, I've got that constant velocity, which will be a straight line on my displacement time graph. Displacement in meters. And that's fine. This 4 then should equate to roughly 20. The 16 point should equate to 140. Now what happens in between is this graph needs to be curved, so that is my attempt at drawing a curve. I seriously hope you guys did better than that when you were actually doing the test. You would have used rulers and pencils. It's actually really fiddly to try and draw this type of sensible stuff on a screen. It's not very nice. So that's the 150 meter mark, and again this should curve to become flat. So that is an increasing gradient at the bottom, increasing gradient, and this is also a curve to 0 gradient at the end there. So those two places where the velocity is changing, the graph needs to be curved, but I hope yours looked better than mine. That's miserable, isn't it? Anyway, that's question 1.